Hi, I'm Fidal from JSP Enviro. We do industrial effluent treatment. So as a company, we are from Chennai. We have been there from 2019. What we do is we work in the circular economy space, especially in the water waste usage. So we work across industries like textile, dairies, and various other sector. So the major problem with industrial effluent, why industrial effluent? Industrial effluent usually have high amount of organic waste, unlike the domestic waste, and it is tough to degrade complex organic matter. So it's not like the treatment technologies are not there. The problem is that you require a very high amount of energy, chemicals, and some other processes to treat it, which adds to the overhead cost or the post-processing cost for the companies. So what we do is we have a technology which is addressing all this. We don't use chemicals, we use bacterial process, so we also don't use much of electricity. So the basic principle is that we have these battery boxes, which is like fuel cells. So fuel cells are basically you feed in the fuel and you get the energy. So here we use bacteria and we have these battery boxes. We feed in the wastewater, which is having a high organic load. And what this bacteria does is it degrades this organic load and we try to recover the energy out of it. So this is the basic principle. So usually in an industry, you have different processes. So for the organic waste treatment, you have something like flocculation where you add the chemical and remaining waste is degraded through biological process called activated sludge, where you pump in a lot of oxygen so that the bacteria can oxidize this organic waste and give a clear water. So this pumping in oxygen requires energy, flocculation requires chemical, and at the end of this, you have like a solid waste which you have to again address it separately as a solid waste handling. So all this problem is addressed in my technology, where we don't pump in oxygen. We use a special kind of, we develop a special kind of bacteria which doesn't require oxygen. And also this bacteria doesn't require chemicals. What it does is it feeds on this organic waste that is present in the water and produces energy. So we are also trying to recover some net energy out of it. So we don't require a huge construction. We are modular. What we do is we add to the modules as the capacity is increasing. So it is scalable. At the same time, it has an energy saving. So we can recover some amount of energy, reduce the sludge handling that is there because we produce 90% less sludge. It doesn't require oxygen, so that's why. So we have done two installations down in Erode. So one of them is a 10 meter cube capacity. So this was one of the first pilot that we have done. So we had the small battery boxes through which continuously the textile water was flowing, and it used to degrade. I mean, it will degrade on site the dyes that are there and give like a throughput water. So it is able to reduce 75% color, 70% COD. COD is the amount of organic load, and 73% BOD in the water. So it's not like it's a standalone system, but it can reduce the load on the existing chemicals or amount of chemicals or amount of energy that you're using for the effluent treatment. So when we do the side-to-side cost comparison, without our technology, it was like around 106 rupees per meter cube. With our technology, the cost can be significantly reduced to 48 meters per meter cube. This is based on the reduction in chemicals, solid waste handling, and the amount of energy that is used. This is the updated version of the product that we just installed in SIPCOT Perundurai. So this is a scalable design that you're seeing. So currently we can scale this technology up to like 5 lakh liters per day. What we have installed is 25 as a pilot. So the same thing, it has a good amount of reduction, 50 to 60% within the matter of around 10 hours. And further, it can reduce the load on the amount of energy that is required in the activated sludge process, and it can also reduce the amount of chemicals. So we did a case study of how much emissions that we are reducing out of this. So it can almost reduce around 80 tons of carbon dioxide that is produced for every 100 meter cube of water that is treated every day. So this is the amount of carbon emission that can bring about. If you look at just the matter of how much it costs, so we can reduce the cost by around 30 to 40%, and based on the capex that is installed for our technology, it can have a ROI between somewhere around 3.5 to 4.5 years.
30 seconds left.
Yeah. Compared to other technologies, it has added advantage, which I have already mentioned, reduction in chemicals, energy, etc. Presently, we are targeting the textile, but we are also expanding into distilleries and other units. We are pre-revenue, so we just have this pilot being converted into commercial order soon. So we can serve other industries like chemical and pulp, dairy, dyeing, where the chemical load is a bit higher. Yeah. So we are tied up with some sustainability partner, which is helping us connect with these industries which are more sustainable conscious, and that is how we have business model developed around it. We have raised some grants and some pre-seed investment. Presently, we are looking for collaboration with the industries to demonstrate this technology and get like commercial order.
Sorry to be disturbing you.
Yeah.
Time is up.
Thank you.